When the Eiffel Tower was proposed, many engineers predicted it would collapse under its own weight, or be blown over by the wind. The tower's critics called it an odious column of bolted sheet metal and a structural impossibility. However, Gustave Eiffel's design contained a hidden engineering secret that ensured its survival against all predictions. The key principle future engineers analyze is the tower's resistance to wind load, a force that increases exponentially with height. Eiffel's calculations for the tower's curve were not based on aesthetics, but on a mathematical formula that perfectly balances wind pressure against gravity. He understood that a fixed structure would snap, so he designed a lattice framework from puddled iron. This specific type of iron is much more pliable than modern steel, allowing the tower to absorb massive forces by slightly moving. The tower actually sways up to 12 centimeters in high winds, effectively flexing rather than fighting the pressure. Another hidden challenge was the ground conditions. The two legs near the Seine River were built on soft river silt and required deep foundations using compressed air caissons, a cutting-edge technique at the time. This asymmetrical foundation design is a brilliant solution to a geological problem. Future engineers also study the tower's thermal expansion. The structure expands and contracts by almost 18 centimeters between winter and summer. The Eiffel Tower is a living lesson in how engineering foresight can turn a structural challenge into a masterpiece of resilience. The tower's genius is that it moves with the wind and sun. In extreme heat, the top of the tower can actually tilt as much as 18 centimeters away from the sun due to thermal expansion. So hit subscribe to the Civil Engineering Blueprint for more structural secrets.